a quick recap on what we have seen in the last class. We have started with the receivers in the last class and heterodyne receivers you are seeing. So heterodyne receiver, hetero indicates that word hetero indicates multiple. So this receiver involves multiple frequencies for detecting a message signal. So from the receiver side, you are seeing, so the RF high frequency RF signal will be incident on your antenna, and by mixing your RF with your local oscillator, you will get back your IF. So we involve three frequencies here: RF, LO, and IF. So IF is essentially going to be the subtractive component of FRF minus FLO. And we have seen the mixer will perform the role of when frequencies are multiplied, we will get sum and difference component. And usually the sum component, which is high frequency, is usually filtered by your low pass filter, and the difference component is going to be the low frequency, so it will be passing to the next stage of your receiver. So some receivers have several mixers, so you will get FRF, FIF, FIF2, FIF3. Finally, you will get back your message signal. Two techniques are possible. One is you keep your LO constant, or you keep your IF constant. So this diagram will indicate those two schemes of a heterodyne receiver. So in the first AS part, you see the FLO is constant. For different FRF, you get different FIF. The second thing you see, FIF is maintained to be constant. For different for different FRF and FLO, you get the same combination of IF. And it has been design wise, they say that the scheme B is going to be very good for them because the intermediate frequency is same, so detection becomes very easy. So that is what is inferred from the architecture of heterodyne receiver. So we stopped with this in the last class. Now we'll continue with some issues in the receiver. So mainly heterodyne receivers, they suffer with the problem of an image. So image, it is actually the replica of anything, right? So here image means you have a replica of the signal at some high frequency. So actually that image is going to be an unwanted signal. It is going to be just like a noise, but that noise is how it is going to interfere with your original signal is going to be the problem of image. So you know that whenever we have the heterodyne receiver, output of mixer, we have two components, sum and difference. So difference will usually be your intermediate frequency. And since when you use cos omega t or sin omega t, we don't bother because as long as we use a periodic waveform, we don't bother whether we are going to use cos or sin. And omega IF, it is the difference between the RF and LO. When you use cos, you have the freedom of subtracting the frequencies in any order because cos of negative angle is going to be the same angle, right? So whether the difference is going to be positive or negative, I am going to have the same intermediate frequency. So it is not mandatory that omega in should be always above omega not, omega LO, or omega in should be always less than omega LO. As long as the difference is equal to IF, I am okay with that. That is the inference from this equation. So the RF frequency can be less than omega LO, or RF frequency can be more than omega LO. But however the relationship is between omega RF and omega LO, as long as the difference is going to be always equal to my intermediate frequency, I don't bother much about my receiver.